Hey everyone, here's our math problem for today. We are asked to simplify the cube root of the quantity 2 plus the square root of 5. You can pause the video and see if you can solve this math problem. Now let's solve this problem together. Our goal is to simplify this expression. And we know that this radical expression is not in its simplest form because there is a radical inside another radical. So in order to simplify this, we must do away with this part where the radical is inside another radical, and we want also to make sure that there is no perfect nth root in the radicand. Let's begin by assigning a variable for the given expression. Let a be equal to the cube root of the quantity 2 plus square root of 5. Now, what can we say about this variable a? We know that the value of this expression at the right side would always be positive because 2 is positive, the square root of 5 is positive, and the cube root of a positive number is also another positive number. In mathematical notation, we say that a is greater than 0. So these are our restrictions. Then let's get the cube root of the conjugate of 2 plus the square root of 5, which is the cube root of 2 minus square root of 5. From here, if we raise a to the third power, then the first equation becomes a cube equals the cube root of 2 plus square root of 5, which is 2 plus the square root of 5. Do the same thing for b. Here, b cube is equal to the cube root of the cube of 2 minus square root of 5, which is 2 minus square root of 5. Then let's add a cube plus b cube to get this value at the right side plus this value at the left side. So this a cube is now this part. This b cube is now this part here. We get the sum. Simplifying, we can just remove the grouping symbol because they are both preceded by plus sign. And 2 plus 2 is 4. Square root of 5 minus square root of 5 is 0. So what's left here is 2 plus 2 equals 4. That is now the value of a cube plus b cube. And let's remember this value because we are going to use this later on. Now let's go back to these two variables a and b. Let's get the product of ab, that is the cube root of the quantity 2 plus square root of 5 times the cube root of the quantity 2 minus square root of 5. Since both of them are under the cube root symbol, then we can just write them under one cube root. So this radicand is now this part, and this other radicand is now this part here. Now, let's analyze what's inside the radicand. We have here a special product of the sum and difference of two numbers. And so we can simplify this radicand as the square of the first number, that is 2 squared, minus the square of the second number here, which is the square root of 5. And simplifying further, 2 squared is 4, and the square of the square root of 5 is 5. We copy the minus sign. 4 minus 5 is equal to negative 1. And so we have a times b equals the cube root of negative 1, which is equal to negative 1. Let's remember this result as well. Next, we now have these defined variables and we have these partial results. Let's recall the sum of two cubes, a cube plus b cube, which is equal to this formula here at the right side. We already have this value for a cube plus b cube, which is equal to 4. So we know this right side is equal to 4. We have here an ab, but we have a plus b here. So we don't have enough information to substitute all of this to this given expression. So let's do some algebraic manipulation. Let's rearrange the order here. So a squared plus b squared equals minus ab. Then, one technique in algebra is if you add some expression and you subtract the same expression, you are not changing the value of the quantity. What you are changing is just the form. In other words, if I add plus 2ab and I subtract minus 2ab in the same side of the equation, it's just equivalent to adding 0, and therefore the value is unchanged. But we need to do this so that we can come up with a form where we can substitute our preliminary results here. So simplifying this, we know that this part here is equal to the square of the binomial a plus b. Then minus ab minus 2ab is equal to minus 3ab. All the rest are just copied. Next, we now substitute 4 for a cube plus b cube, and we substitute negative 1 for ab. So this ab is now negative 1. This a cube plus b cube is now equal to 4. All the rest are just copied. And we simplify. Negative 3 times negative 1 is equal to positive 3. Then at this point, another problem that we have so far is we have a plus b here and another a plus b whose value we do not know. So let's define again another variable. This time we let x be equal to this a plus b and substitute this x to each of these a plus b's, and this is what we have. We copy the 4. This a plus b becomes x. This a plus b becomes x, and this a plus b becomes x also. We copy the exponent, we copy all the rest. Then let's distribute x to this binomial to arrive at x cubed plus 3x, and we copy equals 4. Then write this in the standard cubic equation where the right side is equal to 0. And this is now the equation that we are going to deal with. Now, one technique also in algebraic manipulation is to split the constant so that we can have a form that can be factored. For example, in this case, we can split this minus 4 as minus 1 and minus 3 because this x cubed minus 1 can be thought of as a difference of 2 cubes, and we know the formula for the difference of 2 cubes. Here, negative 1 is just the same as negative 1 to the third. Then in here, there's a common factor 3, which we can also factor out. So let's perform the simplification. Factor out the 3 here. This is the result. And this difference of 2 cubes, because here you have 1 cube, is a special product whose factors are this part here. And we just copy all the rest. Now notice that x minus 1 and x minus 1 are also common. And so we can factor that out. So this part here divided by x minus 1, the result is this part, which is now x squared plus x plus 1. Then this entire term divided by x minus 1, that will cancel the x minus 1s, and the result is this 3. And we just copy equals 0 at the right side. Then simplifying this further, we can now apply the zero product property. We have 2 factors. This is 1 factor, this is another factor. The product is 0. That means each of these factors can be equated to 0. So this part here is 1 factor that is equated to 0. The second factor is also equated to 0. Then it's clear that from here, x is equal to positive 1. And we have here a quadratic equation which we can solve. But before that, let's check first the discriminant of x squared plus x plus 4. Using the formula b squared minus 4ac. And this gives us a discriminant of negative 15, which indicates that the root of x squared plus x plus 4 is non-real. And since our a is a real number, then this will give us the extra root, and we do not consider this as one of the solutions, and we just limit ourselves to the real root, which is this part. Let's remove all the rest. So we now know that x is equal to 1, and x is equal to a plus b. So 2 quantities that are equal to the same quantity are also equal. Also, we know that AB is equal to negative 1. So we now have here a system of 2 equations in 2 variables which can be solved easily. So to solve this, since AB is equal to negative 1, that means that if we divide both sides by A, B is equal to negative 1 over A. So we can replace this B by negative 1 over A. To eliminate the denominator, multiply each of the terms by a to get a squared minus 1 equals a. And writing this in a standard quadratic equation, we have a squared minus a minus 1 equals 0. And this is now the equation that we are going to solve in order to find the value of a, which is the value of the original expression that we want to find. So using now the quadratic formula, the value of the variable a is equal to 1 plus or minus square root of 5 over 2. But we know that the value of a must be greater than 0. It's positive. 1 plus square root of 5 over 2 is positive, and the other root, 1 minus square root of 5 over 2, is negative. This means that the only acceptable value for a here is this part. This one is another extra root because a here is negative. This is not a solution. So at this point, we have narrowed down that the value of a is 1 plus the square root of 5 over 2. And this is now our final answer. Thank you very much.